Welcome back to my channel. Today we are going to do a question on trajectory or projectile motion. This is a step-by-step tutorial in order for you to understand what's really happening here. So this question right here explains to you what happens in this situation. This question will be provided in the description down below with a link, so it will be easy for you to understand what's happening. So I've drawn the diagram relevant for this question. So therefore now let's get on with the question. So the question says that first of all that you should find the velocity component of the particle when it reaches the height a. To do this you should obtain an equation first. To obtain this equation you will the given data the vertical velocity component. We know that the gravitational acceleration is g, and we know also that the vertical height is a. So from here it's very easy for you to understand. From what's happening here is that you should have this equation. Vertical velocity component goes upwards, so therefore you write the arrow upwards, v squared u squared plus 2as, v squared u squared plus 2as. From here v squared is should be found, u squared is 6ga because root will be cancelled off when it is in the power 2, and this will be in minus because acceleration is minus. Therefore acceleration is minus because in a projectile motion, if a particle moves up, the upward motion will provide a deceleration for the particle. This is what makes the acceleration becomes a deceleration. So this is minus 2g a because this is a. Right here we found it. Now v squared equals 4ga. 4ga root is equals to 2 root ga. We have proved the first the first question that they have asked in this question. So now let's find the other answer as well. For this we should obtain two equations, as they have given a data which says that the horizontal range is a in between the walls a and b. So from here we should derive an equation like this: s equals ut plus half at squared. S is equals to a and u is equals to root ga, and time is t as they haven't given time. This whole thing will be 0 because acceleration of horizontal component in a projectile motion will always be 0. So a over root ga equals t. This is equation a, and from here what we are going to do is that we are going to take the equation for the vertical velocity component, which is s equals ut plus half at squared. S is equals to b as they have given here. U is equals to 2 root ga, 2 root ga. Time is equals to a over root ga minus g over 2. T squared is a squared root ga squared. So this is written like this. This and this will cancel off. 2a minus g over 2 dot root ga to the power 2 is ga, and there's a here which will be cancelled off. A over g. This and this will also be cancelled off. So b equals 2a minus a over 2. So this is not all the data that we would need. For this to be b and the horizontal range is a, But now we have found the relevant equation for this part only, but this part is A, so we should add an A. B equals, we should make the denominators look the same. So now we are going to add 3A and multiply it by 2, because we should make the denominators equal to each other. 3A into 2 minus A over 2 equals 5A over 2. Hence we got the answer for the question number 2. Now that you have done one question, you already have mastered the projectile motion, but you should do more questions. I'll be doing one more question in order for you to understand. So I'll be doing this question right here, this one. I'll be providing this question as well in the link down below. So let's get on with the question. So we have this projectile motion going in the system. So then the particle is projected with an angle of pi over 3. This angle pi over 3 is equal to 60 degrees with a velocity of u. And they say that you should find this expression. So now they have given two types of data, which is the vertical height is h, and the horizontal range is k. Now that you know these data, it's really easy to get the remaining things. So s equals ut plus half at squared. S is, we take this as the horizontal range. S is equals to k, u is equals to u cos 60 dot t. Now we know that the cos 60 component is half, so therefore it's 2k over u equals t. You got one equation, simple A. Now you must be able to obtain the second equation. S equals ut to the vertical velocity component. S equals ut plus half at squared, and s equals, the acceleration will be a deceleration, because in projectile motion, when a particle is projected upwards, the acceleration is deceleration. This is what causes the particle to go up and fall down. So when this happens, s is equals to h, u is equals to u sine 60, t is equals to this 2k over u minus g over t over 2, and t squared is 4k squared over u squared. So u and u will cancel off. H is equals to root 3 over 2, because sine 60 is root 3 over 2 dot 2k. 2 and 2 will cancel off, minus this and this will cancel off, and g 2k squared over u squared. H is equals to root 3 minus 2gk squared over u squared. K right here, so this comes to this side, 2gk squared over u squared plus h equals root 3k. Proved. So this is the basic tutorial of projectile motion that I got to do. These are some advanced questions, and it's really easy to understand. It all what requires is some practice, and you can easily do it. So I hope you guys had a great video and a great time learning from me, and I hope you share this video with your friends, family, especially with those who need this type of knowledge. You can recommend in the comment section down below on what content would you need and what content would you like to further see in this channel. And I hope you subscribe, like and share. Thank you.